Good. Just since we are a small setting here, how many are managing infrastructure here in any shape or form? No? One, two. How many are in the application space? Application development? Management? Any others? No? Any other areas? No? Okay, so hopefully, it's. I want to give you a session where I'm not just trying to sell you my solution, right? What I'm selling. I actually want to talk a little bit about the industry and the evolution of the data center, and make sure that I put things in context and not just present a solution. So, but of course, I'm here as part of as a vendor, Datrium. And we sell what's called a distributed virtual solution. We call it DVX. And it has multiple different components to this solution that I will cover during this session. But it's compute, it's primary storage, it's secondary storage, data management, data protection, security, scale out, cluster management. There's a lot of terms here to talk about. But I want to really go back in time and unfold what really people are talking when they talk about convergence and hyper-convergence and what is happening on the market and why are we doing what we're doing today. And then I'll talk a little bit about the evolution of this model. So if you remember, if you have ever managed infrastructure and data centers, applications used to run bare metal, right? You deploy the guest operating system, either Linux or Windows, on the server, and you would install the application on top of that, and the application would live just on hard drives, right? We had local hard drives in each one of the servers. And the world was good. We couldn't really manage at scale, but it managed individually. But then came along a company that changed the data center and how we deploy infrastructure. They invented something called the hypervisor. I don't need to say the company was VMware, right? The first one. Nowadays, VMware is not even in the business of actually virtualizing x86 instructions. Intel is doing that with VTX, and VMware manages the virtualization layer in Intel. With the hypervisor, we were able to start putting all these applications that were running inside our data centers in these called virtual machines or self-contained environments. And we were able to have many of those inside servers, getting greater consolidation. And with Intel producing better and faster processors, we'd have more and more of those. With that, we now started to use full capacity of those servers. The problem with that is that those hard drives that were in the servers were not good at providing performance that we needed. But then came along a feature from VMware itself that completely changed the data center in many ways. I clearly remember the first time I saw a vMotion, a virtual machine running an application. For those that are not in infrastructure space, I'm talking about something that happened probably 15 years ago, moving between servers in the data center while keeping it running. So the vMotion feature changed the data center in many ways. Now you could migrate applications between servers. The problem is that to use vMotion, you needed something called shared storage, or as we all know today, a SAN. A SAN, it's a shared storage that is providing the same bucket of storage to all the servers at the same time. The SAN already existed, but it was not very prevalent because there was no need for it. It was more like used as a NAS, like a storage files and so on. But now with vMotion, the SAN became very important. Everybody needed a SAN, and that's why it became so. You have many companies out there that built their story on top of SAN architecture. You've got EMC, you've got many others out there, NetApp, and so on. But with more and more consolidation happening and more applications requiring more processing power and more IOs and more throughput, the SAN was not able to provide all that. And that said, there are other problems with SAN as well. they were very complex. If you ever manage a SAN, there's things like zoning, LUN, and masks, RAID groups. It's very complex. You need different skill sets to manage all that. In some companies with many different SANs, you need different people to manage all that, right? So it's costly. And at the end of the day, they're not scalable. Some of them you can start small and grow a little bit, but once you need more capacity or performance for your storage architecture, now you need to add another SAN. It's clearly not a good solution, at least for today's infrastructure. But the problem was performance. So with flash becoming a little bit cheaper, vendors said, why don't we put flash in the SAN? And let's create a hot tier, a hot caching tier. Many of those companies are still out there doing this sort of thing. The real truth is that back in time, caching technologies and algorithms were not really good at that point in time, and they're much better now. But that only lasted a little while because applications needed more performance. And some vendors said, okay, so flash is now really cheap, and we have things like deduplication and compression. Why don't we add flash for the entire platform? So they added flash. And then you see vendors out there like doing well, like VMAX, all-flash, and Pure Storage. There are many different all-flash platforms providing a lot of performance, a lot of throughput for applications. But the real problem here is that the real bottleneck was never solved. Now it's like putting a Ferrari engine inside of a Kia. It's not going to work well, right? The problem is that the two controllers the SAN architecture presents itself with two controllers were always the bottleneck. You can't give all the performance that you have getting from flash devices and NVMe and bottleneck everything through those two controllers. That was the real challenge. Some companies looked at that and said, it doesn't make any sense to have flash inside the SAN, outside the server, remote, and have to go through all the network to provide the data back to the virtual machines. Why don't we put this flash inside the servers? Kind of back to where we started, right? So some companies, and early on, like Nutanix, one of the very first companies that did that in production environment, Google was doing a long time ago. They looked at this environment and said, why don't we put this flash inside the server and virtualize those two controllers in each one of the servers as a software stack? So as we add servers with software controller, we are increasing the number of controllers so we'll never run into a bottleneck. That's very clever, right? And it just makes sense to have the flash inside the server so you provide the microsecond latency experience so that you great user experience to the users. We're all used to having flash or SSDs inside our notebooks. Now, I don't think anybody here has a notebook that has a hard drive inside anymore, like a HDD. It's all flash, right? And the way this works is these software controllers talk to each other and sort of like architect the solution and where data needs to move, and it's what's called a cluster. So this SSD though was not enough for the amount of capacity that was required because now SSD was becoming cheaper, but once you're adding in the servers, you can't put all your applications. So they had to add some hard drives, and the HCI solution as we know today, or Hyper-convergence as we know today, or the hybrid solution that has flash and HD was created. And this is what you see from most vendors nowadays, right? It's a combination of software inside the server, and then you have flash, and you have hard drives, and all servers talk to each other, and the solution happens this way. So when you hear hyper-convergence, this is what we are talking about. Now there are some issues with this sort of technology as well. It solved the many problems. I'm going to talk about them, but also created different issues. First of all, most of the vendors will require you to have a specific hardware or a specific server. They may support different vendors, but they will tell you need to buy this specific solution, and that can be a problem for many vendors. The second thing is, in the same time frame, servers were stateless. What does that mean? It means like if the server failed, you restart that virtual machine in a different server, and the server is accessing that data back online, and it's all good. The data was not compromised. In hyper-converged environments, the servers are stateful. There's data living in all the servers. So as you have a server failure, now you have a data resiliency problem. Now there are some mechanisms to mitigate all that, but the truth is, a server fails, you have data unavailability. So you need to work with that. Also because there's a lot of what we call east and west traffic, or like the traffic between all these software controllers, it's very hard to make it scalable. You hear vendors talking about thousands of servers, petabytes of data. The real truth is there's a bunch of different small clusters that is aggregated through a single pane of glass or management interface. And there are other things, like this is on its own, it's a silo again, so you need to forklift your applications, your data into that. But there are great things about hyperconvergence. They solved the big problem. They made it faster, using no SSDs and flash inside the servers. They removed a lot of the complexity around, deploying SANs and zoning and masking and so on. And some of the vendors went further, and they also automated a lot of the things that we do inside the data center, like patch management, upgrade of BIOS, firmware, and so on. This is all very good. So where do we go from here, right? What do we do next? Why am I here talking? I'm gonna say that this is legacy already. So first of all, HCI has been, some companies have been doing for the past 15 years. In tech, 15 years is a long time. And some companies that have been able to assimilate what was good about hyperconvergence, what was good about SAN, and sort of creating a next generation solution. And Datrium is one of those companies that was able to look at the problem and sort of try to figure it out. By the way, we have very early engineers from VMware, principal engineers, people that were the first, 20 people at VMware that just left VMware to start this company. Diane Green, VMware founder herself, is an investor in the company. And we also have people from data domain that invented deduplication. They're part of the company as well. So very good pedigree. So we looked at this problem and said, you know what? It just makes sense to be able to scale your data center, adding servers with a flash, with a software stack, because it removes bottleneck that's coming from HCI. It also just makes sense to have flash in the servers, to have that microsecond latency, great user experience to applications and users. What doesn't make sense is to have the servers stateful, to have data living in there, to not be able to scale large. So the solution that we created is a little bit different, has a new twist, and we converge in a different way. So a lot of the things on hyperconvergence we do, it's got data locality, flash, and scale performance, adding servers. But we store persistent data in what's called a data pool or a data tier. So we always have hot data, the data that is being accessed by our applications, sitting in flash, fully deduplicated, fully compressed, and a copy of the data is always stored here, erasure coded, heavily protected in this tier. So what does that make? Essentially is first, servers are stateless. There is data here, but if I lose the server, all I need to do is upload this data into new servers. It happens automatically, dynamically. The second thing, that enables me to increase performance adding servers independent of capacity. In hyperconvergent solutions, you buy that server that has compute and has storage. If you want to add more storage, you need to add more compute. If you don't want to add more compute, you need to add more storage. It doesn't make sense. You need that independence. Enables you also to leverage existing infrastructure in your data center. So give you the same speed and benefits of hyperconvergence, but using your servers. You don't need to buy servers from us. You can bring your own existing servers, and there's no HCL. Basically, anything that is accepted by VMware hardware compatibility list will be accepted. Some servers will be very old, like 5, 6 years old. They might have some RAID cards that are not compatible, but for the most part, anything is accepted, and you can grow from there. And then because of the infrastructure, we have what's called north and south communication. We can do large clusters. But the interesting thing here as well, here at the top you have your servers, and you have flash. It's all flash here. So you essentially have an all-flash array. Everything is running from flash. This is your primary tier. This is your tier 1. At the bottom, you have a heavily optimized storage solution for your backup. This is your backup. This is your secondary storage. So you have a primary and a secondary storage. Oh, do I need a third-party backup too? It's up to you. We partner with vendors, but if you're putting everything in your data center on Datrium, you might not need. The reality is that in large data centers, you might have hundreds of different solutions. You might already have your backup tool, your favorite backup vendor, and we will work with them as well. And this is what Google and Amazon, the type of infrastructure that they're using today. They are not using hyper-convergence anymore. It didn't work for them because of the scalability. Now they need to move performance independent of capacity. I actually thought about removing Facebook icon from there because it's not very good to talk about Facebook right now. But the reality is that if you look at Open Compute and Bryce Canyon and everything they're doing with Open Rack it's everything going this way, this model. So we are a virtualized infrastructure for virtualization. We do also support bare metal. We do primary data management and have all the features that you'd expect and always on the duplication, compression, erasure coding, and so on. We are secondary data protection. We do your backup, we replicate, we do all that, and we have offsite data protection. And if you are a VMware customer, of course you'll be very familiar with our UI. It just integrates into vCenter and the single pane of management for your entire organization. So we knew our solution is the most scalable and the fastest in the world. But just we know when doing micro benchmarks is not enough. So we wanted to go and test and validate. So we partnered with Dell, and we did the biggest benchmark at scale in history. We did 128 servers and 10 data nodes in a single unified data center infrastructure, a single pool, a single everything together, right? And with fairly old servers, cheap SSDs on the servers, and with all the data features turned on, everything they would expect that you would run in a data center. Whenever we see benchmarks out there, we see a lot of companies saying, oh, we achieved that, but then you see oh, the duplication was disabled, compression was disabled, and oh, we're doing just protection with 2 copies. Come on, guys, this and ladies, this needs to be a real world thing. So we partner with Dell and Intel, and we hired a company called IOMark to do this benchmark. I'm not gonna skip explaining how the benchmark works, and come talk to me later. But basically, the previous world record was an IBM flash array that did 1600 IOMark VMs. The world record for hyper-convergence was vSAN with Optane SSDs. It's a very expensive 3D crosspoint drives, flash devices. They did 800. Datrium did 8,288. It's a different ballpark, a different world, right? It's a whole new level of performance that you're getting with our technology. We just won an award, the best storage technology for 2017. Over half of the this is like the Oscar of storage technology, right? Just over half of the judges gave us the first place. Plenty of customers already using it in all sorts of verticals. Finance. I don't know if there's anyone in finance here. I'm in New York. I gotta talk. I'm from California, but originally from Brazil, but I live in California. Healthcare. There's a lot of things happening there. But I also mentioned. How are we on time, by the way? You're good? Okay. But I also mentioned, if you look at that, I talked about tier 1 HCI. I talked about scale out backup, the secondary tier, right? I didn't talk about CloudDR, and that's where I want to spend a little bit of time to explain to you what we do. So we all know iCloud, iPhones, not sure how many on Android here, but it's fully integrated, right? You don't have to say, hey, back up my data to iCloud. It's automatically there. It happens seamlessly for you. And the data is fully protected, wherever Apple decides to put it. Now we know it's Google, but it's there. For enterprise, a little bit different. You want to make sure that there's data sovereignty and all that. You need to know how it's protected. But overall, you want to have the same experience when you're backing up your data to the cloud. And that is the approach that we took when we integrated our CloudDR with AWS. So it's a as-a-service solution. The only thing that you have to do is provide your credentials in our user interface. So there's no separate backup tool that you need. There's no gateways that need to be configured. WAN accelerators, we have full deduplication across the wire to make sure that everything works seamlessly. It's highly efficient in the sense that we do this deduplication. There's no full backups. It's always incremental. We're also concerned about costs. To not only to move the data, but the real cost with AWS when you store data there is the egress cost. How much does it take to bring your data if you need to bring data back? And it goes directly into your primary storage. If you use a third-party tool to do backups, now generally speaking, it's a backing up from your primary storage, going to their appliance, like a scale-out backup vendor, and then from them it goes to the cloud. On the way back, same thing. You need to hydrate from the cloud, put in this backup vendor, and then move to the primary storage. Sort of like a very cumbersome process that because we have end-to-end visibility of the workloads and the VMs, and we do understand VMs, we can do that seamlessly to you. We actually even talk about do not restore, restart. So basically when you hit restore, it happens just instantaneously for you. Some of the use cases for that, of course, consolidated backup from multiple Datrium systems. You can recover to on-premise, so it's like your offsite backup. They automatically recover. And moving forward, we're also going to provide recovery to cloud. So you might have a single data center, and you want to make sure that if the data center goes down, you're able to reinstantiate those virtual machines or that backup in a cloud service, be that on AWS, on Azure, or anywhere else that we are. Today, we're only going to provide AWS. Moving forward, there are other options as well. But in my session abstract, I also talked about why innovation doesn't stop here, right? So this is what we are offering today. But we're starting to hear more and more people talking about NVMe over Fabric. That's sort of the new technology for providing data access or data repositories. The real truth is we have some customers that have been already using NVMe on the servers for over 2 years now, providing very great performance for on the servers. But over time, we already have an all-flash data node, but over time, NVMe will also be required here. The problem with NVMe is it's a one-to-one relationship. You can't, there's no way to have, and it's very fast, so it doesn't make sense also to have a controller in front of NVMe drives, because you would be bottlenecking everything. We believe that we are in an extremely great position because we do this distributed reverse coding from the servers to the drives. We will be able to provide NVMe type devices for organizations in a much, I wouldn't say better, but like in a more seamless way than other vendors will in the future. Because first, we are a software controller. Everything goes from the software controller to the NVMe devices. We're able to do erasure coding and distribute data. There's no bottlenecks. And because of that, we'll be in a much better position to tackle new technologies as well as they come. With that, thank you. I know it was a lot.